So good morning everyone. Myself Sindhuja from Stella Matutina Physical Science Department. So today we'll be seeing about system of resistors. What are resistors and what are the different system of resistors? Okay. So we'll be seeing about the introduction to the resistors, resistor of series, derivation of resistor of series, and diagrammatic representation, how the series is being diagrammatically represented. And the next one is the parallel resistor, then the derivation of that parallel resistor, then the diagrammatic representation, application, and then at last we'll have few questions to assess to know how well you have understood the concept. So moving on to the topic. So what is resistor? Resistor is nothing very simple. It resists. Resistor resists the amount of current that is passing through a particular circuit, right? For example, 2 amperes, 2 amps of current is passing through a circuit. If a resistor is being placed, not all the 2 amps is being going to be passed to that particular circuit. Some amount of current is being held, and only, for example, it may be 1.8 amps of resistor that is being passing through. This depends upon the value of the resistor's resistance. So the current through a conductor depends upon its resistance and the potential difference across its ends. This is from Ohm's law. Everyone knows Ohm's law, where the potential difference across in a circuit is directly proportional to the amount of current that is passing through that circuit. V is directly proportional to I current, and R is the proportionality constant. So we get V is equal to IR. So in various electrical gadgets, we often use resistors in various combination. We now therefore intend to see how Ohm's law can be applied to combination of resistors. So we have different combination of resistor, and those are series and parallel. There are two types of resistors, series and parallels, and these can be connected in various forms. Two resistors in series and two another set of two resistors in series, and those two can be connected in parallel. And set of resistance parallel and another set of resistance parallel, and both of them connected in series. So the various combinations in which resistors can be connected, but we'll see the basic form, the simple series and resistor. So first, resistor of series connection. Here, if you see in that diagram that I have given, two bulbs, they are connected in series. So here these are the resistance, that resistance is being provided. There is switch and there is battery, and the resistance connected in series. The current flows through one way. There is no other way for the current to pass through. There is just single passage for the current to pass through. So the current in a circuit goes through every component in the circuit because it is connected one after one another in a series. Therefore, all of the components in a series connection carry the same amount of current, and there is only one path through which the current can flow. So now we'll see the derivation to obtain the resistance, the sum of resistance. What is the resistance of that circuit? Rs value. Okay, so we know V is equal to IR. Since the current is same passing through all the resistance, and the potential difference varies across two ends, and there's uh, two ends for one resistor and another two ends for another resistor. For every resistance, the potential difference varies. So potential difference of that whole circuit is V1 plus V2 plus V3 plus V4 and so on till Vn. And the V1, V2, V3 represents the potential difference of that particular resistance R1, R2 and R3. And I capitalize the current. So when we apply Ohm's law to that entire circuit, that is V equal to IR, we get V1 is equal to IR, V2 is equal to IR2, and so on. So from equation 1, if we substitute the values of V1, V2, and V3, we get IR is equal to IR1 plus IR2 plus IR3, and so on. Since the current passing through all that resistance is same, we can cancel them out. We get Rs, that is sum of resistance in resistor of series circuit, is equal to direct summation of particular resistance of the resistors, that is R1 plus R2 plus R3. So we can say that The sum of resistance in a series circuit is summation of individual resistance of the resistors. We get it is very simple. So Rs is equal to sum of resistance of all the resistors which individual values, their individual values. So since it is simply the sum, the resistance, the total Rs value is much higher than any individual resistance. Because, for example, if you connect 1 ohm, 2 ohm, 3 ohm, and 4 ohm, the summation 1 plus 2 plus 3 plus 4, we get a higher value of resistance, which cannot be, maybe this higher value of resistance cannot be manually manufactured. So, by having combination of smaller resistance connected in series, we can produce a higher resistance in a circuit. But this kind of connection cannot be connected in all the devices because there is one drawback. If one resistance malfunctions or does not work properly, short circuit or any of the thing follows, the entire circuit does not get the current supply. That is, the circuit is broken down and there will be no passing of current. For example, third resistor is damaged or malfunctions, then the current passing from 3 to 4 gets stopped and breaks, so the circuit is incomplete, right? So in domestic appliances and domestic uses, domestic circuits, we generally use parallel series of circuit. So next we'll see the diagrammatic representation of the resistor, series resistor. So you see R1, R2 and R3, and voltage is connected. You can have voltage connected to all the resistors individually. R1, both from one end of R1 to other end of R1 1 voltmeter, and one end of R2 to another end of R2 another voltmeter, and so on. Ammeter is connected to know the value of current that is being passed through the circuit. So next we'll see the resistor of parallel. So two or more components that are connected parallelly, one here, other here, and other here. We all know it, parallel. So that is known as resistor of parallel. So the voltage passing through them, there is a potential difference is same because the ends are same, right? So the potential difference is same, but the current differs. The amount of current, it is determined by the value of resistance of the resistor, because V is equal to IR. So I is equal to V by R. V is same. So the amount of current traveling I through that particular resistor would be determined by having the ratio of the potential difference to that resistance value of that particular resistor. That would be found for individual resistor, right? The amount of current that is passing to that particular resistor. To find the summation of the amount of current passing to that whole circuit, or the summation of the resistance of that whole circuit, what is RP? That is resistance of the circuit when it is connected in parallel. So that could be found by, we know, different amount of current is passing through different resistor in a parallel circuit. So I is equal to I1 plus I2 plus I3, and RP will be the resistance of parallel circuit. So we know V is equal to IR by Ohm's law, so I is equal to V by RP. Substituting the values of I in equation 1, we get V by R is equal to V by R1 plus V by R2 plus V by R3. Since potential difference is common for all the resistor, we can cancel them out. So we get finally 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So the sum of resistance in of resistor in a parallel circuit is reciprocal of individual resistance, right? For example, if you have 5 resistors, it will be 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus 1 by R5. After that, we can simplify by having common denominator and taking them to the other side and cancelling them out. So we can conclude that the reciprocal of equivalent resistance of group of resistance joined in parallel is equal to sum of the reciprocal of the individual resistance. So we'll see how it is being diagrammatically represented. So if you see here, the ends of all the resistance is same. That is where the potential difference is connected from this end to that end, and ammeter is connected not at the starting. Here you see there is a difference. It is for in series it was connected at the beginning where the current passes because it's going to be same anyway. But here in parallel circuit it is connected at the end, like that is the end of the passage, that is the closing terminal, because the current passing through is not going to be the same when coming out because it's in parallel circuit. So now we'll see the applications of resistors. So there are several applications. So the principle of resistor can be applied for heating elements in iron toasters. There are many toasters, right? So in specifically iron toasters, heaters, hair dryers that dissipate voltage as heat. Dissipate means nothing. It's very simple. Dissipate means outflow of energy in the form of heat. For example, if you have a glass of water, hot water, so you can feel the warmth, right? Some warmth when you place your hand on top of that glass. You can feel some warmth or warm air near that. That is this. The heat is being flowing out of that particular quantity, volume, or device. Here, our device is a glass of hot water. Hair dryer dissipates heat. When you on switch of a hair dryer, we get hot hair. And when you on a toaster, the coil gets heated. You can see a red color iron gets heating up, and you can see heat on the which has been dissipated, and due to that, the bread gets toasted. And water heaters, so there is some water, the coil gets heated, and the heat is being transferring of heat, right? That the is being transferred to the water. So that is dissipation of voltage as heat. And then in new generation automotive, LED light cluster. LED is light emitting diode. They demand a specialist resistor solution. See, resistance need not be always in a physical form. They can also be in the form of solution. Anything that resists the flow of current can be used as a resistor. Um, in the below diagram, the first diagram is the LED, the representation of LED. The next one is the aluminum clad wire wound. Wound is nothing but you see that golden color outer surface. So the aluminum clad wire, right, that is being wounded throughout the resistor. The black color is the resistor, and throughout the surface it has been wounded till the end of the resistor, right? Like a cylindrical surface, it has been wound up around the resistor. This provides even more powerful uh, uh, how do you say, like the heat which is being transferred, it has been totally controlled. It provides more amount of resistance. It provides high power dissipation in a limited space, and is designed for high heat sink mounting. High heat sink mounting is, if you consider a glass of warm water, the amount of heat is going to be less. And a heater, the heat is less. We are able to tolerating. We are the human body. We can tolerate that heat, right? So when the amount of heat is very very large and we cannot tolerate, we cannot control it under the normal conditions or normal substance devices. So we use such special devices, adding aluminum clad wire around that resistance. So this controls the amount of power that is being transferred from that particular device. It is being held inside, and only lighter amount of heat is being dissipated or transferred out or sent out. So this, by using this, a maximum thermal compound, a compound is what is a compound wall? Even in your home or school you have a compound wall, right? A boundary, a border for that particular area or region. So a thermal compound nothing means a compound which is constructed like imaginarily, okay? So a compound which is constructed so that it indicates the amount of heat is within that particular area and doesn't come out of that area. So the same way in this particular device, heat is just within that golden color surface and it does not come out. So that is aluminum clad wire resistor. Now time for assessment. So I request everyone to answer the question read out the question, write down the answers, pause the video, and then pass on play the video after few minutes, and you will get to know the answer in the next slide. So the first question is, the ratio of the potential difference to the current is known as dash. The wiring in a house consists of dash circuit. LED stands for dash. In parallel connection, the amount of current is same passing through the all resistor. True or false? So you can pause the video and you can play after a few minutes to know whether the answers is right or wrong. This helps to know your understanding on system of resistors and to know your weaknesses and your strength when where to study more. So the answers are resistance, parallel, light emitting diode, and false. So these are the reference sources from where I have taken the material. Thank you everyone for listening to the video. Thank you.